this over. Okay, will you try this practice problem real quick? It's a Le Chatelier's principle question. See if you can answer these 4 questions. Ready, set, go. Is established by placing solid of this ammonium hydrogen sulfide in an evacuated container. What does this mean right here, by the way? All right, that takes in, or it's endo, or heat would be on this side. You okay with that? Okay, also notice this is a solid. These are both gases. Okay, at equilibrium, some of this remains. Predict and explain each of the following. So we want to know the effect on the equilibrium partial pressure of NH3. So we want to know what happens to this if we add more of this. If I add, I go where? Away, which means this side goes up or more, and this side decreases. You okay with that? So we would say more NH3 is formed. Your explanation would be that if you add to one side, you produce more of the other. So far, okay? Okay, next. Oh man, this has been terrible today. It's like it doesn't want to work third try. B, the effect on NH3 again when additional solid H2S is formed. Oh, solid. That's interesting. Well, that's okay. It's still H2S, and that's gonna sublimate, essentially. It's gonna increase the amount of this. Are we okay with that? If I add, I go away, which means NH3 goes down. What's that, Tolman? Yep, force it away. Okay. Oh, this is so, what the? I hate that. That was very ferocious. You're a good man, Judah. All right. What does volume decreasing really mean? All right, you're increasing the pressure. Here's 0. Here is 2. So is there an imbalance? Yes. Circle the bigger number every time. Then if I add, oh, this one's tricky. So if I add solid, I would go, I'm not adding, I got to read. If I increase the pressure, I go away from the side with more. So if I increase pressure, I make more solid. Okay. Okay, it's just stuck right there. Imagine I circled it 3 times. So if I increase the pressure, I go to the side with a fewer number of gaseous moles. So the amount of NH4HS increases. It's okay. If I have a gas and I pressurize it, I'm going to make more solid. Okay, I don't know if this is working at all. Oh, sort of. Okay, here we go. Letter D, the effect on the mass of solid NH4HS present when the temperature is increased. If I add, I go away from the heat term, so that would make more products, which means the reactants actually go down. So NH4HS goes down. Fair enough. That is Le Chatelier's principle. What? Le Chatelier. I get it. All right. Whoa. Are we good? Oh my God. She was ready to throw hands. A catalyst increases the rate of both the forward and reverse reactions. All right, the rate, it's increased both. When we talk about equilibrium, we're talking about forward and reverse. So equilibrium is achieved faster, but the equilibrium composition remains unaltered. So what this is saying is if you have a catalyst, they will cross earlier and go flat earlier, but they will still be flat at the same spot. So it's important to know that a catalyst does not have an effect on the equilibrium expression. So temperature and pressure are not catalysts. Catalyst is usually a chemical. So like the decomposition of H2O2 is catalyzed using potassium iodide. I don't know. All right, so this catalyst would be Ki. Because it's not a product or a reactant. And equilibrium is the products over the reactants. It does, but equilibrium is like comparing the height of this to the height of this. We don't care if that happened here or here. Doesn't time-wise doesn't matter.
Doesn't the equilibrium get changed if you add a different amount of products, change the temperature or the pressure?
Yeah, those three matter, but not the catalyst. Yeah, for sure. And they're in our food. They're called antioxidants or preservatives. Antioxidants are the good ones that do that, but preservatives they're not super good for you. But that's why tons of the food you buy at the store doesn't have to be refrigerated. It's because it's full of things that slow the rate down.
Like the non-refrigerated.
That would definitely have some stuff in it. I don't want to do that one. Okay. So here's the effect. I want this word. Make sure you understand this. It's a little tricky. Here's the effect of adding an inert gas. An inert gas or noble gas, such as helium, is one that does not react with other elements or compounds. Adding an inert gas into a gas phase equilibrium at constant volume does not result in a shift. This is because the addition of a non-reactive gas does not change the partial pressures of the other gases in the container. It can increase the total pressure, but not the partial pressure. While it is true that, well, this is what I just said. While it is true that the total pressure of the system increases, the total pressure does not have any effect on the equilibrium constant. Rather, it is a change in partial pressures that will shift in the equilibrium. If, however, the volume is allowed to increase in the process, the partial pressure of all gases would be decreased, resulting in a shift towards the side with a greater number of moles. Okay, this is a very, very common question on the AP test. You'll do all this math, you'll answer some other questions, and then it said, what would the effect of adding neon to the container have on the equilibrium position? And you are going to say none. And then it's going to say justify your answer. And you're going to say, sure, but those were all true, but you should say it does not affect the partial pressure of the independent gases. Because it doesn't. We learned in chapter 10, the pressure of a gas is independent of any other gas present. So that's because they don't interact with each other. That's why we say an inert. If they don't react with each other, then they just cruise around doing their thing. And they don't really affect the pressure of anything else.
What is the point of noble gases? Like,
well, can't say that there's a point or not a point. They are things that exist.
But they don't react with anything. They don't do anything.
Right, but sure. Most of them make it lower though. Okay, here you go. Practice problem. We're almost done with chapter 15. Still debating on actually giving you the chapter 15 test. Oh, well. They are hard. Okay, try this problem. I'm going to pause. I would like you to try it without talking about anything. All right. Why did I put 0.5 here? because it says initially it's 0.5. Then if it doesn't tell you that these are anything besides 0, then you assume they're 0. I'm going to put a minus, I'm going to put a plus, and I'm going to put a plus. All right, now at equilibrium, SO3 is 0.2. So the change was 0.3. This change would be the same because they have the same coefficients, right? So this is positive 0.3, but this change would be half as much because it's 1/2, 0.15. So I have 0.3, 0.15. Now my KP would be equal to my products. So 0.3 squared because of the 2 right here times 0.15. You don't have to put it, but I'm going to say to the first because the coefficient is a 1. And this is all divided by 0.2, which is squared. And we end up with some answer.
0.3375.
Yes.
Can we do one where we have to convert the KP to the K?
Okay, sure. What's KC then? Whoa, hello. Thank you. She's not here. She kind of self-parent releases.
You initially wanted to move to where I.
I don't remember. Who has this written in their notes, this equation?
I do, I just don't.
All right, hold on, Gabe. What is it?
Isn't it product of reactant?
No. Well, that's true, but that's not what I'm looking for. You got it, Walker?
No, it's up
I have it.
Yeah. Okay, hold on. No one talk but Nisha. What? Yeah. Okay, so KP equals what? KC, sorry, equals. She rearranged it.
Oh, I forgot. Will
All
I
right.
be given this equation? or-
You won't be given that version of it. You'll be given the other version.
Which we can just
All right, so now we take it and figure it out. So we have 0.3375 over 0.0821 times 1000. Wasn't that the temperature it gave you? And the change in moles was just 1, wasn't it? Was it positive or negative? Positive 1.
Wait, where did you
No.
change your moles at?
It's positive. It's the moles of your products, which is 2 plus 1, minus the reactants, which is 2. All right, it's going to be a pretty small number. Do I get a second? You do? Okay. Okay. Now, the answer Reese said, is this equation on there? And it's not. It's written as KP equals KC times R times T to the delta N. But Nisha just rearranged it for us. So this is given to you. You have to be able to realize KC would be that divided by this. Okay, fair enough. Okay, I think we. Do you want to do this one? Okay, we did one a lot like it, but a little different. This is it. This is the last one, I'm pretty sure. All right, here we go. So, my friends, 0.64, 0, and 0, because that's what it gave me. And then at equilibrium, I had 0.16 of N2. So I had 0.16. Oh, you're so lucky. I made that easy because it's the 1. All right, so that means this was plus 0.16. This means this was plus what? 0.48. And this was minus That's 0.32. Okay, now don't, on the AP test, if you got a question like this, don't just leave it in the ICE table. You must answer this question. So you would then say, all right, of Cl2, there is 0.48, of NCl3, there is 0.32, and N2 is 0.16. Make sure you answer the question. You all right with that? Okay, the value of Kc, you would plug the values in. It would be these two divided by that one. So Cl2 is 0.48 cubed. All right, times N2 is 0.16. And I divide that by 0.32 squared. Is everyone okay with that?
Yes.
All right, I type that into my calculator and it tells me it is what? 0.1728 or 0.173. All right, who had that part right? Raise your hands. Okay, well, I thought it'd be better. The value of Kp, so Kp is equal to Kc times R times T raised to delta N, correct?
Yes.
I plug that in, I have 0.1728 times 0.0821. Whoops, hold on. Times temperature was 400, no, 673. Oh no. And then it's 4 minus 2. So it's squared, right? Yes, Grace. It kind of matters. If you, let me answer her first. It does matter, but if you plug all that stuff in divided by the volume, you should get the same answer because everything's all cancels it out. You could at the very start if you felt like it. If I remember right, I think so, but I'm not positive. So that might be a good question. Okay, word what square? This square? It came from 3 plus 1. That was 4. So it's the moles of change of products minus the moles of reactants. So that becomes your exponent for delta N. In the equation, it's delta N, change in moles, products minus reactants, or final minus initial. All right, what do you get when you put this in? 520 point. There we go. All right. Now, according to Kc, Kc is this value, product or reactant dominant? Reactant. Justify. Less than 1, it's small, which means we have a few products and a lot of reactants. It depends. It's 99% on Kc, but if it said Kp, you could answer it. All right. Total pressure inside the flask at equilibrium. This is chapter 10. This is Pivnert. So the P, it's PV equals nRT, or P equals nRT over V. N is the sum of all of these. Times R times T. Whoops, not 0.2. It was just 2, right? 26.5. Okay, don't forget the other chapters refer to other chapters all through. Okay, that was this problem. Then if neon is added, what happens? No change because the total pressure changes, but the partial pressures don't. What we mean by partial pressures is we mean that these stay the same. They don't care about the amount of neon present. If you can do that problem, you can do the one on the test. Really, I don't know. Do you need this up still? Okay, this is the same stuff. What is mass action expression? That's KQ or KC. Yep. No, don't worry. I didn't draw it. I didn't draw it, so I don't know. You've seen my art skills. Okay, try A through F here. Oh, it's not the same as the one we started with. It is different. Give it a shot. Wonder where my man Garrett went.
We keep coming to this little fun thing that every trimester there just gets a little cluster of AP Chem students. Wait a minute, Garrett was here today.
Yeah, I definitely saw.
Yeah, I know. It was
Yeah,
kind of weird.
it's okay.
He was here, but he didn't. I mean, yeah, I'm one of them. But I stayed. Nisha.
I've talked in your car before, but for going to class.
Tell him.
Take which class?
Oh, I really need to read the question before I do anything.
Oh, we'll take a nap now. Oof. Should have nominated myself prom king. Thank you.
I would've been great.
Thank you.
I would've voted this one.
I would have voted for you too.
Thank you. Maybe I'll be the prom king of the teachers. Yeah.
Teacher prom.
Oh, a teacher prom.
My wife.
Good answer. Good answer.
Yeah, I was gonna say you had to would ask first.
Yeah.
Everybody's like.
All right. Let's go. Oh, this doesn't work. Oh, is it? Whatever. I'll just stand up there. It's good for me. Okay. suppose the substances in the reaction above are at equilibrium, yada, 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 yada. So we're defining what happens to NH3. Everything, we're defining it as NH3 experiences in it. All right, so if we add NH4Cl, what happens to NH3? It goes up. The temperature of the system is increased. All right, this is positive, which means heat would be a reactant. That's a lot fatter font than I was ready for. So if I increase, I go away from the heat, which means NH3 goes up. The volume is increased. That really means I'm lowering the pressure, right? I'm just going to scribble. That says decreased pressure. All right, so then I got to come up, I check. There's a mole here. Bless you. 1, 1, 1. So we have 2 on this side, 1 on this side. Circle the big number. And if I decrease, I go towards the big number. So what happens to NH3? It goes up. We okay with that? Right here. If I decrease the pressure, I go towards the side with a larger number of gaseous moles. NH3 is on the side with more, so that's where it goes up.
Say that again, if you decrease.
If I decrease the pressure, that's what these two awesome words say. If I decrease the pressure,
Then you go
I go towards the side that needs more room. That would be the 2 than the 1. So I go towards NH3, which made it go up. Okay, next, HCl is added. If I add, where do I move? Away. That would cause NH3 to go down. NH3 is added. Kids get this wrong all the time. You're like, I added, it must have increased. That's wrong. That's what we do. We want to know what the equilibrium does. If I add, I go away. Okay, anytime you add, you go away from there. And then the pressure is increased. Once again, we had a 1 on this side, a 2 over here. Circle the big number. If I increase, I go away from the big number. So what happens? It decreases. Okay, feel all right about that? Okay, this question is on the test.
Can we do another one like that?
Not today. This question is on the test. And what else is on there? There's some multiple choice, which if you watch the videos, we've gone over, I think, all of them. Like the first one, you'll remember the answer probably without even looking. All right, let me just come over here for a minute. I'll change the numbers so you can't memorize the answers, but it'll look like this. You have this information, what direction the reaction go to achieve equilibrium, whatever. You can figure that out. It gives you KP. So if it gives you KP and it gives you these, that's a K and Q question. Then we've done that problem and that problem before, like exactly, and then we just did this problem. I know that was fast, but you'll get over it. Okay, so 3/4 of the free response we just did today. Yes, Judah.
Like earlier last week, like it was like Tuesday or Wednesday, you said you were gonna give us like a strip of paper with numbers on it, right?
The one with variables? Yeah, there'll be some variable questions.
And this is probably Wednesday.
Oh, 100% Wednesday. I could give it to you tomorrow, but
Do it.
I like Wednesday. Just
no,
keep it on.
Wednesday it is. No.
I wanna do it tomorrow.
All right, well, it was medium fun teaching you today. I don't know what to do.